So hope my screen is visible. Can anyone please confirm whether the slide is visible and I'm properly audible? Hello. Am I audible? Can anyone please confirm? Am I audible, Deepika? Okay, so let's start this week's discussion. It's about Markov decision process. So this is week 10 and you people must have learning about Markov decision process, which is also known as MDP. So if you have any doubt, any question in between, please feel free to interrupt. Right. So this session is for discussion. So feel free to interrupt in between, no issue. First, I'll discuss few important concepts regarding MDP and reinforcement learning, and then I'll solve few relevant assignment questions, and we'll discuss few more numerical regarding these concepts. What is MDP? MDP is just an assumption, and assumption says that it's like a very philosophical thing. You must have heard by your elders that whatever you have in hand, just continue with that and you can gain anything, like that, right? So MDP is also like that. It says future is independent of the past given the present. You have present information, you are at the present, don't think about the past. What has happened had happened. Now you can start it from here and you can do your future depends on your present. This is what overall it wants to say in one line, if I have to say. So this Markov assumption is that if you have complete information about your current state, you are good enough to judge what would be the next to be done, right? You don't need the past information, what I had done before 7 days. This is the Markov assumption. So for example, I have to take a tea or coffee. It's completely depends on what is the current situation. It doesn't matter last week I have taken tea or coffee. But in life it matters. Last time I took the coffee from here and it was not good, so obviously I'll try something else, right? So this is also can be formulated using this equation. S is a state. What is the current state? Given the state information, this is the current state at th timestamp. You can whatever action you will take is equivalent to, you have all the information from S0 to ST, right? So for example, let me give it example. Should I buy coffee or tea? This is your action, and ST is what is the current scenario, and ST minus 1 is what has been done yesterday, what has been done day before yesterday, and like that, since let's say 7 days data we have. So it says that whatever the current information you have, it is good enough to decide what you will do in next. So it says that you have current state, that's fine. Based on that, you can decide what to be done next. This is the Markov assumption, and whatever you will do in MDP formulation, numericals and reinforcement learning, it is based on this concept itself. The formal definition of MDP you must have read that it is a 5 entity tuple. S is your state. What is state? State you must have hearing from first week. State is information about environment. Current state means what is the current scenario of the environment. For example, the environment around me is a table, chair and a room, right? So this is my environment. So and the position of each entity in this current state current environment represents the state. This is the ST, state at, let's say, at timestamp 7:11 p.m. This means state. What is action? Action is set of possible actions. what I am doing given the state. I am moving, maybe my actions would be talking and moving slides up and down like that. So this comes all under action space. What are rewards? Reward function depends on how you respond to me. Are you people are getting the idea? Is it making any difference in your learning? Is it either it may be positive, it may be negative, both. So reward function, it says with the given tutorial or the teaching session you are getting, your concepts better clear, or you are just, your time is getting wasted with that. So reward could be positive and negative both. So given state, I have taken some action A. State means this laptop, let's say current state. Action means what I have talked just before a second. This is my action, and based on that, however it will respond, it is good, it is bad, something like that. So this will be the reward. So reward is depends on two things: what was the state and what action you have taken. So it's a mapping of state comma A to R. R is your reward function. Yeah, so I was talking about MDP. So this S is a a set of possible state, A is a action, and R is a reward. I was just enumerating all the information in the current scenario. This is laptop current state is slide number, let's say 246, whatever it is. Action is what action I'm doing. I'm talking, I'm saying something and moving the slide up and down. So all this comes under action space. Reward, your feedback, whether positive, negative or neutral, this will be a reward. P is a transition probability distribution over the next state given ST and AT. What does that mean? It means that which state I am going given the state I was in slide number 247, let's say. Action was whatever you have told. Maybe you have told that, sir, I didn't get the previous concept. So my action would be to go in the previous slide, right? So this ST plus 1 depends on what was the current state and what action I have taken. Based on that, my next action would be decided. If you say, okay, this concept is okay, you understood it, then I'll go to the next state, means next slide. That will be your next state, ST plus 1, given ST and action was to go on the these things. So these four things must be very clear. Another thing comes discount factor. This is very tricky. So if you understood these four, that's very good. But this concept, discount factor, what does that mean? It means that let's say someone is giving me reward, for example. I let's say I taught this concept and you are saying, sir, I'll pay you 200 rupees, right? That's okay. So you are paying this 200 rupees. You say, sir, you have two options. I'll pay you 200 rupees today, or I can pay you maybe 250 rupees after 3 years. What would be the efficient or the good action? To take 200 now, because after 3 years, 250, it's just increment of 50 rupees and that will not make much sense. So I'll choose 200 rupees for today rather than 250 for next after 3 years, because it says what is the value of the reward at the given stamp. So gamma decide whether you should focus on current reward or you should focus on future reward. So this gamma control this factor. I think you must have got the idea of current feedback and future reward or something, delayed reward we call it as. So now MDP must be clear. So I just give you an again overview, because this is whole you have to do. In exams you will have some given environment, they'll ask you what are the action state and all those things and do some formulation about that. So state is, let's say for this example, my slide would be the state. Slide number 246 is the current state. Action would be up and down, going previous slide or next slide would be the action. Reward would be what you are saying. You are saying you understood concept, you didn't understand concept, or it's neutral. So this should be the reward. Transition probability will be what would be my next state given ST and AT. Will I go to the slide number 300 or will I go to the next slide? This depends on the current state and the action I have taken. Discount factor, the idea I gave you, please try to connect with that. I said the value of current reward at the current stamp matters most compared to you are getting some reward after 3 years or the 5 years down the line. That is obviously important, but it is not equally important as the current reward. In today's life, everyone is like depend on current reward, current feedback, current positive impact, rather than have patience about the future. Everyone is what will happen today, what will happen is tomorrow, and something like that. But learning is not like that. It consider what are you doing today and what it will make after 7 days. The difference also we take into account. That delayed reward also we take into account is the reinforcement learning. You must have heard also the term HMM, very relevant with the MDP. It is known as the hidden Markov model. What is difference between hidden Markov model and MDP is that in HMM each state has an action AS available from it. Unlike the HMM, we have this difference here. If you see, so there are a few similarity and dissimilarity. If you see the like HMM, we have state S beginning with the initial state. In reinforcement learning, in MDP also you'll see some initial state S0, and also in HMM you'll find something similar to that. The difference is that if you see, unlike an HMM, we also have action. In HMM there was no action, it was only transition probability going from one state to another state. But here also actions are possible, given the state what you will take and what you are going to do about that. So these are the difference between MDP and HMM. So main difference was the action. There was no such action, but here we have action. And another thing was in HMM, S dash depends on S, but here we have also additional information action A. So that's why it depends on both. Now coming to few examples. Whenever you see any MDP problem, first thing you have to find out this information. In any question, in any situation, if case study will be given a MDP, you try to find out what are the states, what are the actions, what is reward function, what is the objective. These are very important. This game all of us must have played. So it's Atari game. I don't know if people have any idea about that. Deep learning, recently in 2016, if I recall it correctly, something DeepMind released, and in a lot of many Atari games, more than 100 Atari games, the DeepQ network performed very well compared to even human agent. Those who are playing, they beat champions and all this kind of thing. So what is state here? State is this current screen is the state. What is, if you go in depth, what is state? State is this green box, after there is a blank, after green there is a blank, and like this, where you should hit, and it is giving you some information. Actions, you have only few action control, left, right, up and down. Oh, is there up and down? When I was playing in Nokia, some phone, small Nokia phone, it was only left and right. There is option of up and down? I don't think so. Okay, let it be. So actions will be your game control, what you have in your hand. Reward would be what is happening with your score, whether it's increasing or decreasing at each time stamp with your given action. So this would be your action. Reward would be the numbers on the screen, the scoreboard is the reward. What is objective? Objective is to that you should learn an optimal function. Don't confuse with the function, policy, and everything. Don't get stuck with that. It's just a function. Given a state, what action should I take? This is the policy. You must have heard lot of times policy. If you have seen the this week lectures, which is MDP, that maximizes reward. You have to learn an function, learn an optimal functions which maximizes reward. So given the situation, you have to write a function which will take x is a state, and give you y is the what action should I take, whether a0, a5 or a3, which action should I take. Here there would be 4 actions: a left, a right, a up, a down, right? So given the state, what should I do? Another example is a cart pole. So what are the state information here? State information is what is the position x and y, let's say coordinate, what is the velocity of this arm, what is the angular position, what is angular velocity. This is the current state information, and how will you go about it? Once again, I request everyone to please try to join before 7:10. It becomes really, uncomfortable for me to stop slide and go and take you in. I may miss you. I already told you last week, but just again a warning. I may miss you to make you in the session. Yeah, so I was talking about this impermanent. What is the state? What is the action? Action would be +1 and -1, which translates to the movement either to the left or right. Reward would be +1 provided for every time step if the pole remains upright. Okay, so this is another example of MDP formulation. If you see, this is another one game where it is known as a card pole. There are various versions, B0, B1, B2, and this is why this is B1 version, where the objective is to make the pendulum state upright. It should not fall either left or right. It should be upright. This is the goal, and till how much second you are making it upright, you will get reward based on that. What would be the action? Action will be +1 and -1, which translate to the movement of either left or right. You have only two actions, either go to left or right. State would be what will be the position, what will be the velocity, angular position and angular velocity. So when I'll give you a problem, I'll say what is the state. You try to find out all the information that should be encapsulated to decide what next action would be taken, right? So whenever I'll ask you some question, please try to formulate state like that. This is my current project which I do. I think in first meeting itself I told you my area of interest is NLP and reinforcement learning. So here this again, I have worked on a lot of RL based projects. So this is one such project where we have used RL based agent to do symptom investigation and diagnosis. So here what was the problem? Problem was that let's make a virtual diagnosis assistant. Virtual diagnosis assistant, what it will do? It will given the state information, what symptom should be asked. Finally, what is the disease at the end of symptom investigation, it will do and say this is the most likely disease. So state would be patient self-report and other observed symptoms. What patient is, patient chief complaint, which is also known as a self-report, and what are the other symptoms that doctor or the virtual assistant had observed. This all information will be encapsulated into state. Reward would be action would be which symptom should be asked next, and reward, if patient says yes, I'm suffering from that symptom, then you think okay, virtual assistant is doing good, so reward would be positive. But if you ask something and patient says no, I don't suffer, it is quite relevant to my problem, then you say okay, the behavior of the virtual assistant is not adequate. Objective, what is the objective? Objective is to make the virtual assistant intelligent so that it can do symptom investigation and finally do accurate diagnosis. So let me give you an example so that you will be understanding how MDP, because understanding MDP is very important, because it's like you will be given a problem and they'll ask you how will you formulate it into MDP problem. So you need to make it like identify these information: state, action, reward and objective. So for example, patient comes and say, hey virtual doctor, I am suffering from headache and cold. So this is your state. Current state is that the patient has symptom cold and headache. This is the current state. Now what action should I take? Should I ask leg pain or should I ask fever? Obviously most likely symptom would be fever rather than asking leg pain. So I ask in one scenario, do you have fever? Patient said, yes, I have fever. I understood, okay, whatever I have done, it's correct. I will get +1. In another scenario, I ask, do you have leg pain? The patient will look me like alien and say, oh, what the hell is happening? Is it relevant to my condition or not? So in that situation, it's like getting a penalty to the agent for being asking leg pain in this scenario. What would be the objective? Objective would be finally to learn a policy, to learn an optimal policy which can do symptom investigation and diagnosis. So this is real world problem. This we have done using RL technique, and this idea and this formulation finally has been also patented. And we have made a software based virtual assistant and finally making it into hardware so that it can be deployed in any hospital to assist doctor, not to replace them. Doctor would be there, but their time would be saved for symptom investigation and diagnosis. That draft for report would be prepared by this virtual assistant, and finally doctor will see what the assistant has said, and based on that it will do final diagnosis and treatment he or she can plan accordingly. So this is a real world problem that we worked on to make a kind of virtual assistant to a doctor which will do symptom investigation, and here completely we have used RL part, reinforcement learning, to do so. So this is another MDP example. I'll discuss few problems, but before this, these all problems are based on few concepts which is very crucial to grasp it. I just highlight it because you must have watched the professor videos and it's good enough to answer any question, but still I'll just give you emphasis. What is the reward hypothesis? This is very important. So there is a professor known as a Balaraman. He is in IIT Madras. So he used to give this example quite often. Reinforcement learning, he used to give example, how he started, doing bicycle riding. Is there any possibility anyone give you a set of rules A, B, C, D, E, F, G, H and give you that rules and you go and start cycling? No, it is not going to work. You are going to fall down. Whatever you do, you'll have set of rules, that's fine. This is going to give you a guideline kind of thing, but finally ultimately you are going to learn by yourself, even though someone is with you to assist, but you have to sense every time. No one can say. So this is completely like a reinforcement learning problem. You'll fall down, you'll understand, okay, given the situation, whatever I have done, it was not appropriate, so I must have done something differently. You are again in the similar situation and you said, no, I should put my legs down in such situation, and you did it and you found you didn't fall. Then you understood, okay, so this was the good action to do. Ultimately you have to make a balance in cycling. I don't know how many of you know cycling. Most of you must know. So this is a real world scenario to understand how MDP or RL formulation has been done and understand. So you must have heard the objective of any RL is to maximize the reward. The cumulative reward should be maximized. But what is hypothesis behind is that whatever ultimate your goals, that can be described using maximization of expected cumulative reward. So ultimate goal is to learn a task T, and that can be represented with maximizing reward function, maximizing cumulative reward. So implicitly you are learning a task by doing capital R maximization, which is cumulative reward over episodes. So these are few examples have been given. For example, make a humanoid robot. So positive reward for forward motion and negative reward for falling over. That is good enough to make learning efficient so that it can walk around. It is getting positive reward for motion and negative reward for falling over it. So I'm giving a very simple example. Please try to understand this example very carefully, because it will give you complete idea about how MTP formulation led to RL problem setting and finally optimize. I have made a small robot. It is in a room, and I let's say it is at the desk of the room, and I want it to be at gate. This is my goal. Goal is that robot should be at the gate, and the coordinate of the gate is, let's say, 10,23. Currently it is at, let's say, 0,0. I want it to be 10,3. It is at desk. I want it to be there. So goal is 10,23. But I'm not going to give this information to agent. I'll give this information implicitly through rewards. How should I design reward? Can anyone say how should I design reward? The bot has 4 options. Left, it can do 4 options. Going forward, going backward, going left, going right. These are the 4 actions. How should I design the reward so that it can implicitly capture the goal that it has to reach to get, and which coordinate is 10,23. Any input, any suggestion? How can we do this? So think for a moment, because for any decision making problem you need to think either right or wrong, but every time it will give you some clue about what should be done. I'm giving you a bit of clue so you can think it as like coordinate system 0, 0 to 10,23. An agent can take either left, right, forward and backward. You are at state S, which is 0, 0. You will go to the next state when you will take an action.
Yeah, so if we
Hmm.
go to the left, right, so it will be negative. We are going negative, right? Negative axis, so you'll be negatively rewarded, right? You are
Of
going right, you will be
hmm.
positively rewarded. You are going up, you will be positively rewarded, and if you are going down also,
Hmm.
you will be negatively rewarded, right?
So you are saying let's make left, right and backward to -1 and going forward to +1.
+1.
Will
Yes.
it work? It will reach to it will reach to where? N, 0 because it will always move upward. So 1, 0, 2, 0, 3, 0, 4, 0, like that. It may reach to 10, 0, but again you have to also move it to right, no?
Yeah, yeah.
Yeah, so think about that as well. But it was right, good. One heuristic. So I used to take also in IIT Patna AI lab. There is a AI subject, and we used to have lab in session once in a week. So I always say them, whenever you will get a problem, don't go for efficient solution in one go. You understand the problem and try to find out brute force solution, just the naive solution first. It should work, and then try to find out optimize it and find out the optimal solution. It's like a 2 steps. So here you people should have to come up with the solution. Yeah, that solution works, and then you can at least make it optimum like that. Okay, so coming to the problem, it was you are at 0, 0 and I want the robot to go to the gate which is 10, 23. How we are going to design the reward function. So idea is that it is a state S, fine. It can take left, right, up and down. I'm not going to restricting it. Let's say it took left, right and up, any of it. It will go to another state. Let's say it took, let's say right, which should be your going right means y going right would be increment in x coordinate, so it would be 1, 0. Perfect. Now I have to decide whether it was good move or not, going right was good or not. So what I'll do, I'll see what was my initial distance from goal, what was the Euclidean distance, let's assume from 10, 23 when I was 0, 0, what was the distance, which will be 10 minus 0 square plus 23 minus 0 square root over. It was the distance d1. Now I came to 1, 0. What would be the distance, whether it has reduced or not? So it is, let's say d2. You calculated, which will be 10 minus 1 whole square plus 23 minus 0 whole square root over. So this is become d2. I'll see whether distance has reduced or not. I'll find out, I guess distance has reduced, right? Then I'll say it was good move. That's okay. Whatever I have taken, it's okay. So what was the initial distance? So reward would be like, if st minus 1 g, st minus 1's previous state and g is the goal, the distance between st minus 1 and g to stg, whether it has reduced or not. If it reduced, if it is less than 0, then I'll say whatever the move what you have taken, it's good enough. So I'll give it, let's say, +1. Otherwise, if it has increased, I'll give it, let's say, if it has increased or same, I'll give it -1. I'll give it a penalty. Then bot will automatically figure it out that what action it has to see. This was very simple example, but it will give you the complete idea about the MDP formulation and how we are going to optimize that process. So after the session, if possible, you just write it down, this problem, and write the code for it, how the bot is finally learning it, and it will finally reach to the goal after some action, some steps when it will converge. You don't have to say because it was not decided, it is not deterministic that in any state left action would be good or the right would be good or up and down would be good, something like that. So that fine-grained information we don't have. So why not to encapsulate goal information through reward? This is the whole idea of reward hypothesis. Think about our final goal G and try to enumerate that goal using reward function. Any question, any suggestion for as of now?
Yeah, I have Abhisek, I have one question. So in this case, you don't have to give any static reward like 1, 2, 3, 4 like that, right? You want to only optimize the distance, right? Like the distance you had earlier and current distance, and then you optimize on that. Okay.
Now coming to the policy, you are going to hear a lot of times. Complete this week, next week, and next to next week also. So policy, very simple concept. Given state, what action should I take? So this is just a function which maps state to action. Policy is as simple as that. What is optimal policy? Optimal policy is that you have learned a policy which is acting optimally for a problem. This is optimal policy, and it is denoted by pi star. And what is A star? Whatever you take from pi star given state S, that will be optimal action, and it is denoted by A star. What is our objective? Objective is to find out a pi star. to find out a pi star. What would be the pi star for a given problem, which is, and now let's take some time to digest this equation. I'll give you some example and then try to enumerate this information. I am in hostel, IIT Patna hostel, right? I need to go to gate. What should I do? Should I go to department first? Should I go to gate 1? Should I get to gate 2 or something like that? Should I take, which move should I take? This is the overall goal. What I'll do, I have, let's say, 4 options. Again, like I'm also a mini robot. Left, right, up, forward and backward. So your current action, whatever you are taking, what you will get some reward. That's right. But it also give you some clue about the future, right? If I'll take a move which is going to gate 2, then coming to gate 1 will be very difficult for me. I'll take steps S1, S2 and S3, and then I'll discover, okay, from there is no path, right? So I'll again revert back and again start another direction to explore. So overall point is that for a given action, you shouldn't get reward based on locally. You have to think globally. Given the action, that's okay. I may get a reward for that. So for example, think about a scenario. You have played that many games now. Whether it should okay, something like, there was a flower, I went there, I took it up, I got a reward of plus 50. But after a second, when I moved in that direction, someone came and, in like a game, there was a people with gun and he or she fired. I know the player died here. So acting locally is not good enough. You have to think globally. This was the idea. I think it makes sense. Your action doesn't only determine what you're going to take now, but final overall thing what is happening. Should I invest in bank 1 or bank 2? Currently bank 1 is giving 8%, that's fine, but after a few days the reward changes. So you need to think about the globally what is happening. So that's why I don't think that every time I should get a positive reward. I'll think whatever the total R, capital R, which is somehow over at the current timestamp, next timestamp and next time, that I'll try to optimize rather than optimizing local reward. I'll try to optimize total reward. And total reward look like this. Means I have policy pi. I have, let's say, assume you have learned a function policy p. This is the pi. You have learned what action should I take given the state. I have learned it. So with that policy, I'll take action. I'll get a reward at 0th timestamp. If you'll put it 0, it will be R0. For first action, I got R0 and gamma ki party, which will be 1, because anything power 0 other than 0 would be 1. So you are getting R0, that's fine. Let me write it down for you, which will make much more sense. So I'll try to always optimize capital R, which is total reward, rather than focusing on R0. So I started with R0, that's fine, because as I said, it will, gamma factor would be 1 here. Again, gamma into next reward would be R1. Plus gamma square into R2, something like that would be there. Gamma into gamma. Gamma is a discount factor. I said now what weightage will you give to the current reward and future reward? It's not equally important. I don't know, what's your intuition? Should I focus more on the current reward or should I focus on future reward more? It's a very subjective question. It depends on the problem itself. Should I take 1000 rupees per class now, or someone will give that for that class 1500 after 5 years? I'll always take this 1,000 rupees as of now. It's not far sighted or something like that, but you need to weight your reward with given the situation. So total reward is that at the current timestamp, okay, fine, you got R0, you reach to the next state. What action you have taken? You are getting a reward R1. So I'm multiplying with some factor, gamma, which is between 0 and 1. So this was very important. This is bit less important. I went to another state, S2, let's say. I took another action, I got a reward for that, which is R2. Right? So I am adding it up, but I'm saying this importance should be a bit less again, because gamma square, it should be again lower down. This reward is important, this one is bit less important, and this one is a bit less important compared to this one. So overall we'll do the sum, and then I'll decide, given the state, what action I should take. So it didn't only depend on this one, it didn't depend only on R0. Should I take A0? No. You should always consider overall thing. If I have taken left and maybe there is a dead end, there was no good, for left I got a reward of 50, but this is not good move. I could have taken right, which was giving plus 10, but I had the option to again go right. I'm getting again plus 10, going again right, plus 10. If I'll do 10 times, I'll get 100 rather than taking that left move and being stuck at 50. So your decisions should depend on long term thing, very realistic thing. In life also, should you go in company 1 or company 2? It's not about giving you salary for first month, maybe after 2 months it will make you layover. So it's not a good decision to choose that company given the situation and circumstances. Now coming to this problem, this is the goal state. Start is the goal state, and you are at the any state. What should you do? Should you take right, left, or up and down? This is the random policy. You are in the any state, you can have 4 options: left, right, up and down. But I am asking you to design an optimal policy. The optimal policy would look like this. So if I will be at this state, let's say I'm at this state, always good to do up rather than left and left is not possible, right or downwards. From there, good option is to go here. From this, good option is to go right. We are here, so we have 2 options. In 2 steps, I'll reach the goal here, 1 and 2. If I'll go this way, I'll also reach in the 2 step itself, right and then down. If I'll be here, it is saying all 3 you can take. You can go this way, you can go this way. So if I'll take this one, I'll take this and then go, only 2 steps. If I'll take this one, this and this, again 2 steps. If I'll take this one, again it will be 2 steps. That's why it's mapped 1 and 2. You don't think about this could also be possible, because here it will be more than 2. But it is saying up means there is an optimal policy going here. That's why it is giving you all 3 are equally optimal. For this one, you see only up and right it has showed. Why didn't show the left? Because it is reaching here a goal in very less steps. It's only 1 and 2 steps. From here 1 and 2 steps. So optimal policy is this. Given state, what action should I do? If I'll give you information, you just say you have 5 state S1, S2 and S3 and you have 3 action. Policy writing is just give me a table, what should I do? So don't please get confused with the policy. Policy is a very simple thing. I have seen the people get confused a lot of times, and this is the basic. So I'm giving an example. Let's say I ask you, there are 5 states and 4 actions. What would the policy look like? I will say, please learn anything and give me the policy. How will you give me policy? if someone can say this is a very great, you have to understand what is exactly policy is. Policy is not imaginary. Finally, what is the policy? How we'll finally express the policy? There are 4 states and no, there are 5 states and 4 actions. It is just this thing. You are at S0, you are at S1, you are at S2, you are at S3, you are at S4. 4 states are there, and let's say 3 actions are there: A1, A2, A2 and A3. So your policy would something look like this. Given a state S0, what should I take? Should I do A1, A2 or A3? It is saying, oh, you should do A1 rather than A2 and A3. So this all will be 0. For S1, it is saying, no, don't take A1. It is not good for this state. A2 is good enough, and then it is saying that. For S3, it is saying A1 is not good, but A2 and A3 is equally important. It can go to the same kind of reward. For S3, it is like A2 is good, optimal here. Don't take A1 and A3. For S4, it is saying A1 and A2 is equally important. You shouldn't take A3. So this is finally your policy would look like. Given a state, what action should I take? If you can express it using a table, this is the policy. Policy is not imaginary thing. This is the policy. This is how it looks like. You can also express it with some function f of x, which will take current state S0 as input and tell whether it should be which action should be take. So output would be 0, 1 and 2, means whether first action, second action or third action. What should I do? So I think now policy should be very clear what is the policy and all. We can discuss again few problems and then come to state. So let us see what could I give you. Okay, so this is the problem. What would be the reward you'll get it for this action? Let me give you this table so that it makes sense. You people first try to calculate it, and then I'll help you to calculate. Now let me explain the problem itself. So it is saying you are in some situation, you are using Facebook. The most likely probability is that you'll use the Facebook, 0.9 probability, and another with the 0.1 probability you will go to the class from Facebook using Facebook as state. You are in class, probability of taking another action is going to sleep, going to party after the class, and another possibility is again go to the use Facebook. So with 50% chance you will go and do Facebook again. You will sleep, 0.1% 0.1 probability, and after class you will go for party. This is 40% chance. You are in party, after the party you will go to sleep, 50% chance. You will go to class, 50% chance. You are sleeping and all this probability you will sleep. This is 100%. This is student Chan, but I don't know how many of you uses Facebook now. It is generation 3, generation 2 uses Facebook. We are in next stage. So this is the student chain and asking you what will be the reward for this state. If I'll do class, I'll do again class, I'll do Facebook, I'll go for class, I'll do party, and I'll sleep. What reward we are going to get it? Now we'll ask reward for each state. From Facebook to class, what reward you will give? From Facebook to Facebook, what reward you will give? This thing you will be asking, and this is there. From this thing you take it and try to solve. So let me put it here. so that you people can do it. Yeah, so please try to calculate it. You also need gamma function. Gamma assume some value is gamma factor is 1 by 2, gamma is 0.5. Now you calculate what reward you are going to get for this sequence, what reward you are going to get for this sequence. This is pretty easy. As I said, now you are in class, start with class. From class to you are going class, huh? So from class to class, what is the reward you have to see? Class to Facebook 0.5, class to class, this should be there, it is why it is blank. Facebook to Facebook it is given, Facebook to class it is given. Also class to class there is, there must be some reward. If it is 0, no one. That's a realistic scenario I am thinking about. From class there is transition to sleep and there is a transition to party. Class to sleep and party it is filled, but class to class there is no such transition, it is saying, or what? Facebook to Facebook there is a transition, and that's why Facebook to Facebook it is given some number, what reward you are getting. From sleep there is only possibility going to sleep. Yeah, so let's assume that this C is redundant. So the sequence is C FB FB C PS. What reward you are going to get it? So we start with from C to FB, what reward you are getting at 0, plus gamma into from Facebook to Facebook, from Facebook to C into gamma square, plus C to P gamma cube, plus gamma की power 4 into P to S. You calculate like this, please. I need answers from all of you. This is pretty easy problem. So you'll get to know how sequence works, and finally you take action based on that. And also calculate the reward for the second walk.
To see there is no reward, right?
Hello. Hello.
Yeah, we can hear you.
Am I audible? Yeah, please can you repeat what you said?
Yeah, I am telling that for C to C there is no reward, right?
C to C, sorry, it is the probability. From C to C there is no path. From class to class you cannot go.
Mm-hmm.
And that I was also wondering about why they have given C to C in random path itself if there is no way to go. There is it is there here, it is saying, I think I did it by myself. From C to P it's 0.5. Okay, class to class reward is 2, then it is giving. With what probability? Because from class to sleep 0.1, class to party it's 0.4, total becomes 0.5. From class to Facebook 0.5, sum up to 1, then how class to class is possible? That's true.
Yeah, what is gamma, Abhishek?
1/2. So is it has anyone done it? What is the number for the first sequence? So walk 1 is this: C to C, then FB, then FB, then class, then party, then sleep, right? The reward would be from class to class. You are in a class, that's fine. You are again getting you are going to class, which is reward is R is equals to 2, putting plus 2 into I said reward is something like that na. It was like R0 plus gamma into R1 plus gamma square, gamma square into R2 plus dot dot. So we are doing the same thing. R0 is 2 from class to class plus 2, from class to Facebook, which is minus 1. Gamma is 1/2, so it will be 0.5 into minus 1 plus, you are in Facebook and you are doing Facebook, so it would be minus 1 again, 0.5 square into minus 1. From Facebook you are going to class. Facebook to class is 2, reward is 2, so it will be gamma cube 0.5 keep power 3 into 2 plus class to P. P is the party, from class to party, which is plus 1. So your gamma keep power 4 into party is 1 now, so it will be 1 plus party to sleep. Sleep is 0, so anything you multiply with 0 it will be 0. So whatever this number will sum up it to, this would be the reward you will get it for this random path, random one. Is it clear? Any doubt, any question till there? Similarly, you can calculate also for the other problem, right? So this was the solution. It would be like from class to class, 2 plus 2 into 1 by 2. This is the gamma square, gamma cube, and everything is happening. And finally, we'll sum it up to, it will come something like that, 2.63. Don't confuse with this y3 minus, because some numbers become 3. Positive numbers would be 3 and negative 1 will do, it will do 0.65. Again, for this one, what would be there? How to learn an optimal policy? You are at the S1. This is a very important slide. You are in S0. You had 4 options: A0, B0, and C0 and D0. If you see locally, you will say the best action is C0. I'll take C0, but this is not the optimal action, because if you take S0, C0, you will reach an S12, and from S12 you have this option. Going to you will from if you'll take optimal this one C0, you'll reach to S13, and from S13 you'll go to S25 and S26. From there is no way to reach to this goal state. It will be blocked. You will reach to some dead state and you will get penalized for something, right? So don't think about locally, you'll think about globally. So it's like a backtracking. If I'll find out this path, which action should I take? So the value of this state, the easiest way to say it, like, what is the value of S11, what is the value of S12, what is the value of S13 and S14 in terms of what is the reachability of goal from this state. This would be the value, and if value is high for the state, take that action. So here this one S1 would be, A0 would be more beneficial, because from here you will be able to reach to the goal. So overall, I wanted to give this example to show local reward is not enough. Agents should care about cumulative reward rather than immediate reward. Any question, anything about this slide? So for this action, this state A0 was optimal rather than taking local action plus 5. So value of state is how much reachable goal from this state, with what action, how many actions. State value would be high if reachability of goal from that state would be high, and that too in less number of steps. So this is finally in reinforcement or MDP you want to do. Objective is that you learn a policy which maps current state ST to next state. Another question, if you see this example, you must have, this is our robot, it is here in S9. S6 is the dead state, and we want to go to this state, this diamond state, and S8 is the state where if you'll go, you'll be dead. This problem you'll find it there. We need to find out a policy. Policy means at any state I can say which action should it take to reach this global goal state. This is the policy we have to learn. This value calculation, please see it carefully how we are doing finally value calculation. So let's say we are at the S3. What will be the value of S3? Value of a state is which action is giving you maximum reward to next state reward. So this is the formula for this one, and from there everything has been calculated. Set my state is stuck. Yeah. So value of state, please see this example. Value of state is you take an action A which is giving you the maximum reward R of S A plus what you'll obviously do transition to another state S dash, right? If you take action at a state A, you will be reaching to another state S dash. So whatever reward you will get it for taking that action A, you do plus what is the value of next state. It's like a recurrent solution, right? I am at, let's say, third floor of hostel. Should I go to second floor or fourth floor? I have two options. If I'll go to, I have two options, whether should I go to second or third. So I'll go to fourth floor because there is my friend, and if I'll go there I can talk with him. So I have chosen this one, going upward, plus what is the value of that state, value of floor fourth. So value, I am at the third floor, I am asking what is the value of the third floor. So it is like value of third floor is equivalent to value, you will get a reward for transitioning from third floor to fourth floor, which is RSA, plus what is the value of fourth floor, right? So value of the fourth floor plus current reward whatever you got. So this is how it has been enumerated, recurrent solution, and based on that everything is calculated. Let's calculate and see whether it works or not. Any question, any doubt in value iteration? This is very important concept.
Yeah. So Abhisek, this RSA,
Yeah.
this RSA, which state are we taking? State 3, right?
Yeah.
State 3. What is the value of state 3? S3. The value of S3 is it?
Yeah, we are calculating value of S3. So value of S3 says you want to know my value. So what you do, you are in S3, you have 4 action. So you take any of action which is giving maximum reward, A3, you sum it up, reward for S3 to A3, plus you must have transitioned to some another state, value of that state. Did you get the idea?
But VS dash, why is it 0? I mean,
because you already reached at this goal state. So here it is R of SA from S3 to R of SA is your 1 because you are going to goal state, and you are in value of this is defined already, V of S dash, value of S dash means goal is the 0, that's why it's a gamma into 0, it is 1. So B of S3 we got, it is 1, we put it here 1. Now we will calculate what is the value of S2. So value of S2 is saying, okay fine, we are in S2, you take an action which is giving you the maximum reward to wherever you transition, you take the value of that state into gamma factor, right? So it is R of SA. We are in B of S2 and we have what options we have. Let's check it there. Should I go right or left? If I'll go to left, there is no way the optimal action is going right because I'll reach it to S3 and S3 to I can reach to goal. So it is saying
right.
Yeah. So I'll take this action, I'll go to right. So reward for going to state 3 plus value of that state, value of S3 here. In previous attempt we had the value of S4, but we are reaching next state to S3, that's why it's a value of S3. So from S2 to S3 reward is 0, that's why 0 plus gamma is our 0.9 discount factor into what is the value of S dash, value of S3, it's already we calculated, it is 1. So we are putting 0.9 into 1, finally the value of S2 is 0.9, we updated it 0.9. Is it clear?
Yes. Right.
So similarly we calculated value of, yeah.
Suppose we are moving to S1.
Suppose we move into state 1. So we are at S2, you are saying we moved into S1. Fine.
Okay. S1.
So what is the question? I didn't get you.
No, one question is what is our goal? What is the goal point?
Like goal point is this
S4.
diamond one. S4 is our goal point.
Okay, so going through S1 will not help, right? Ideally. Like it
Exactly.
is not optimal, right?
No, C is saying when agent is learning, let's say it don't know whether it should take S3 or S2.
Some other place, no? That's why.
Okay. Yeah, yeah, correct.
Yeah, so in RL setting, what usually we do, initially you are starting training an agent, you ask it to do a lot of exploration. So in training phase, it will take S1 and S3 both. But when it will take S1, it will get to know from there going to S4 is not optimal. So it has learned that S3 is the good action. As a human, we can see, that's why we are saying we should take S3. But how agent figure it out? Through learning. In exploration stage, it takes both S1 and S3. Is it clear?
What are all the information which are available while solving this problem?
Only information about this one information you'll have. This is the where your agent is, and what is the reward function from transitioning from one to another state. So idea is that from transitioning from any state to other state would be 0 other than reaching to the goal. If you reach to the goal, reward would be 1. Otherwise, S2 to S3 reward is 0, but S3 to S4, this is the goal state, would be 1. S5 to S1 is 0. S7 to S8 reward is -1 because it has highlighted. This information you will have, and you have to fill this table. So in your assignment also you will find some question like that. It will give you something like that and say what is the B of S1, S11. You have to find out of that, figure it out and calculate this value. Here the question was what is the value of S9. Now let's calculate the value of S9 last. So value of S9 is that it is saying I am in S9. Where is the S9? This is the S9. We have to calculate B of S9. So from B of S9, what action should I take? If I'll go S5 or should I take S10? Which one is the more optimal? So from here we can figure it out. The optimal one is, which one is the optimal? The value is not given. Based on that we can decide which one is the optimal. This is not filled, that's why I'm not taking this example. Let's say we want to decide B of S5. What is the value of S5? So we have two options. Either we can go S6, we can go S1. Three options. We can go S9. Wherever you would go, the initial action would be 0 plus what is the optimal action? Optimal action is going to S1. Because you always want to go to a state where value is high. You don't want to go to S9 because its value is 0.66. Here the value of S1 is 0.81, that's why we chose this one. So it will be 0 plus gamma always would be there, gamma 0.9 into 0.81 value of S1, and then finally the value of S5 would be 0.73. So by intuition also you can see as a human it is decreasing. Here we have, obviously if you will reach to this state means you are very close to S the goal, so value of that state would be high. Value of S2 is comparatively less than S3, comparatively less than S1. So just a scenario, I am doing PhD, so it's most likely I'll get what my dream job, what I want to do, compared to when I was in BTech. So I have to go a long way, right? So just try to relate with this, but it's not a fact. People in PhD have comparatively less, options compared to those who are in BTech. So exploration is more in BTech and compared to that. So idea was to show you that what is the really meaning of the B of S1. Value of being in PhD is in general with is more than value to be in MTech and something like that. So here the value of S3 is high compared to S2 because in only one step you are going to reach goal. If I wanted to be a, let's say, assistant professor, which is not the true case, so I am in PhD, in just one step I will be in assistant professor. But when I was in MTech S2, I have to take one more step. I have to do PhD and then I can have to be this assistant professor. I was in BTech. BTech, MTech, PhD, kind of. And this would be school and all. Okay, cool. So let's do some more questions and see how it is going. Why is the discount factor used in MDP formulation? That gamma, why gamma has been used? This is the question. Don't see the options. First you think about, okay. So what is the intuition of that using discount factor? Why not it is like R0 plus R1 plus R2 plus R3 plus R4? Why gamma is multiplied there? This is the question. Yeah, so first was, if it would be, there is no gamma, it would lead to infinite series. This is the first problem, right? 2 plus 3 plus 4 plus 5 plus 6, something like that, finally reaching to the goal that way, leading to. So in order to make it horizon to be diverged, to finally convert somewhere, you are multiplying with the gamma which is between 0 and 1. So it's like a geometric series, you must have remembered. So if gamma between 0 to 1, it would be your converge here. So this is why we have used gamma here, and which is always between 0 to 1. If it will be 1, then again it will not converge, because it will be R0 plus R1 plus R2 plus R3, like that. To model that only actions that are in our control, not the outcomes. No, this is not true. There is nothing like outcome and action in our control. To capture the intuition that the cost in present timestamp are less important than timestamp cost in the future. No, value of 100 rupees is always, more than value of 100 rupees after 10 years. So this is contradictory. So it is the true to capture the intuition that reward in the present timestamp are more important than same reward in the future. The example I gave you, 100 rupees today or 100 rupees after, let's say 101 rupees or 110 rupees after 10 days, not 10 days, let's say 2-3 years. Obviously, I'll always choose this 100 rupees today. This is another question. So this was previous last year assignment question, I remember. So this is the situation they have given. You are in S0, you have option A00, A01. You reach to the S2. From S2 there are two actions, A21 you will reach to S1, or A20 you will reach to S4. From S4 you have, this is the goal state S of G, and this numbers have been given. If probability is not defined here, means from S0 you are going to A01 here, and from S4 these are the action. So it is asking what? It is asking P of S0, pi of S0 is A00, means you are in S0, the optimal action is A00. You are in S1, this one, the optimal action is A1, go to the S2. So this is how they have defined the policy, asking what will be the value of state S0 under this policy. Okay, round the answer to do decimal. So it is asking what will be the value of S0. Just we calculated. How to decide the value of S0 is, from S0 what is the optimal action you have. Optimal action is already defined, it is A00. So value reward you are getting for A00 is, it's always there, all action cost 1 unless and otherwise stated. So reward for that one is 1 plus gamma into whatever the next state you have reached, gamma into B of S2. Fine. 1 plus gamma into, now we are expanding S2. So value of S2 is, what is the optimal action to take from S2? For S2, optimal action is A20. A20 going to S4. So again reward is 1 because it's not stated always 1. So 1 plus, you are reaching to the S4. So value of that state. So gamma already specified somewhere, I guess 1. So that's why I am removing gamma here. So 1 plus 1, this one coming outside, plus value of S4. What is the value of S4? Is it mentioned somewhere 2? Yeah, this C equals to 2 is the cost. It should be mentioned here. So value of S4 is 2. So plus 2 into B of SG. From S4, optimal action would be G. That's why they have given this, right? A of 41. Yeah, A of 41 is leading to S0. So B of S4, so it will be 1 plus 1, 2 plus 2. B of S4 is 2 into B of, plus B of SG. SG is here, it is given. B of SG is 0 because always if you are in reach to the goal, it will be 0. I assumed it, so it will be 4. So just one confusion, C equals to 2, is it for S0 or is it for S4? Otherwise this is the formula. I already told you how to calculate value of a state. Value of a state would be, what action should I take from that action which is going, which is giving maximum reward? That reward plus whatever the next state you have reached, value of that state, like recurrent. So you can calculate like this. Another question is the
Abhisek, one question.
Yeah,
Like
please.
in the last this picture, why we are not multiplying gamma? I mean, every time we reach one step,
Correct.
I mean,
correct,
outer
correct.
than the step we are in.
True.
Why we are not multiplying gamma again? Like
We are multiplying, gamma is 1. That's why it's not making sense.
oh,
Gamma is 1, then the value would be same, na? We are multiplying. Given value for the gamma is 1.
yes.
So it will. The MDP has, this MDP whatever discussed has which of the following properties? Indefinite horizon or fitness? Acyclic, is it acyclic? No, it's not. Deterministic? No, not deterministic. There was probability things is there. From there you can have probability to go S0 at 0.6 and take going S3 is 0.4. That's why it's not deterministic. Finiteness, yes, it's a finite. What is the incremental rule? Simple average for action values. This is very important. So I don't know you have watched the video about Q learning or not, but it is saying what will be the value of Qn plus 1 if you know Qn. So I don't think you people have watched that video, so let me give you a pretty simple example. So how you update our errors, how you update a value. I calculated value of a, let's say state S is X, but this is not correct. So what I'll do X equals to X plus, what was the error term here? Gamma. Let's say error was del. So del into some multiplying factor. We call it as a learning rate in machine learning and deep learning when you back propagate error. So here it is also similar to that. Whenever you update the next time Q value, it is like previous Q value plus what you have predicted and what is the true, that estimation, how much you are wrong, into some learning factor 1 by n. So this is the solution for incremental rule. Does it make sense? So it is like X dash means new value, new estimation for X is X dash, previous value of X plus some learning rate 1 by n, it assumed. N is the number of steps. It could be 0.1, it could be 0.3. So people also take deterministic, no issue. Into what you have estimated and what was there. this difference Rn minus Qn. This is interesting question. So based on this question, this concept only, Qn plus 1 equals to Qn plus alpha n into Rn minus Qn. So in any policy, what is happening now, you please try to understand this problem, because in theoretical you are finally learning what is the policy and everything. Policy is something, this value function is look like this. This blue one is the target. Finally your value function is something similar to that, and you are learning. This red one is the learning curve. You want to fit it there. You want to go very close to this blue one. You are learning and finally going. So this curve is also going like that, but it's not complete fit. So this is the target and this is the estimation, two curves. Now it is asking, what is it asking? Given the estimate in rate, what do you think, what is the value of step size? It is asking what is alpha n. This we have to calculate. Someone can think about it and just say, and otherwise I'll say why it is. So based on this equation only. Okay, so let's explain. So this is red one is finally we are learning, and blue one is the target. So what I'll do, I'll take points t equals to 1, what was the estimate and what was the true value. At t equals to 1, estimate was 2, but final one was 4. So I'll put it here. So Qn plus 1, what was Qn plus 1 was 4. So I'm putting 4. Let me write it. So at t equals to 1, true was 4, our estimation was 2, plus I don't know what is alpha, so I'm putting x into how much difference it is, 4 minus 2, which will be 2, right? So finally if we'll calculate what would be the x equals to 1 by 2. Yeah, see, so 2 estimate was 4.
1 by 2 or 2? 1 by 2 or 1? I think it's 1, right?
No, it is it 1? I'm making some mistake maybe then. Let me check. So I took t equals to 1, that's fine, I'm taking t equals to 1. Okay, I'm making mistake. At t equals to 1, if you see, what is y? Our y is here 0, and the estimate, this point is we are talking about, so it's 2, and the estimate was 4, fine. What is x into Rn minus Qn?
Four minus two.
No, I'm making some mistake probably. So okay, so this is n plus 1 and this n, it's not n plus 1. This is where I was making mistake. So let's take Rn is the true estimate and Qn is R estimate. Rn is the true value and Qn is R estimate. So it is saying Qn plus 1. So we are going to consider, let's say n equals to 1. N equals to 1 means this point, fine. So our value was 2.
2, right? Yeah. 2 equal to...
Not 2, sir. It would be, here we are considering n equals to 1, fine. But this qn plus 1 is saying what is q2.
4.
It is asking for 2. What was your estimate? It is 3 here, right? So 3 equals to, what is qn you estimated? It is 2 plus I'll explain, x into, what was rn? R1, what was R1? It was 4.
4.
4 minus, what is
Minus 3.
qn? At the end point
Qn is 2, right?
is 2. So finally it would be 1 by 2.
Then it's half.
Yeah. That was, I was missing n and 1 by 2. Now it's correct. So the alpha is, learning rate is 1 by 2. Now this is, I just repeated, when you start learning, you do lot of exploration. When I was 10, I was thinking about doing job J1, G2, J3 and like that. But now, yeah, I'm in PhD and quite sure what I'm going to do now next. So in initial phase, we do exploration. So agent also learn like that. It do lot of exploration and finally figure out what was the optimal action to do in the next future, right? So
Which your voice is not coming.
okay, sorry, sir, is it coming now? Hello.
Yes. Okay.
Okay, thank you, man. So I was saying, what is exploration and exploitation? So when I was 10, I was doing a lot of exploration to figure out what should I do in my career. But now I have already passed so many years and in PhD, and I'm figure it out what to do. So with this given information and exploiting. So when agents start learning, it do exploration, and after some time stamp, it do exploitation. Whatever it has learned, it exploit that information, right? After 40 years, you were all going to do income some point. Learning is always there in real life. It never stops. So whatever what you have learned, you must exploit that one to figure out, your profit or something like that. So 0.1 is saying epsilon means 10% time you will do exploration and 90% time you will do exploitation. This is the meaning of epsilon. What is the epsilon? Epsilon is exploration rate. If exploration rate is 0.5, I'll do 50% time exploration and 50% time I exploit. When I was 5-year child, I have two options. Should I eat rice and curd or should I eat pizza? If my epsilon was very low, was 0.5, I could have taken pizza or rice and curd, both possible. But at current time stand, my epsilon is 0.1, means only 10% time I'll do exploration. Otherwise, I'll use my knowledge and do. So as 0.9% time, 90% time I'll do exploitation. So today at any day I'll take curd and rice rather than pizza. But this is not really, just to give you example. Many of you don't disagree with this, but just to make you aware what is the exploration and how is it useful. So we have designed curve. This blue one is base possible. That's what we wanted to learn. And these are the curves with different epsilon. If you'll do exploration with 40% rate, this is how your curve look like. If you'll do exploration with 10% rate, this is how your curve look like. If you'll do exploration with only 1%, this is how your curve look like, and this is given. So it is asking, why did the epsilon 0.1 perform better than over 100,000 steps than 0.01? It is saying doing 10% exploration is better than 1% exploration. Why? This is the question. You have option, the agent which is doing 1% exploration explore too much. Do you think those who are doing 10% exploration, that will explore much, not 1%, right? So this is not going to work. Epsilon of 0.1 is optimal value for the epsilon in general. No, not true. There is no thumb rule. Epsilon you need to figure out. It is like a hyperparameter of a model. It needs to be learned. The agent with the agent which is doing 1% exploration didn't explore enough. That's true. If you are doing exploration of only 1%, you are not doing a lot of exploration. Thus, it ended up selecting suboptimal arm. So the third option is going to be right. Similar question to this figure again. So it said, okay, fine, you are saying doing mode exploration was good. So asking why not 0.4? Why not 0.4 is very close to the optimal one. 0.41 is this violet curve. Why it is very lower? Because in previous slide I told you na, doing mode exploration is good. So it is asking why not this is close. This was the question. The first option is epsilon of 0.4 explores too much, often thinks it takes many suboptimal action, causing it to do worse over the long term. Epsilon of 0.0 is greedy, thus it is always choose the optimal arm. Epsilon of 0.1 doesn't explore often enough to find out the optimal action. Which one is true?
First one.
First one, epsilon of 0.4 explode too often that it takes many suboptimal action, causing it to do worse over long term. Yeah, that's true. So it explores too much. So it's good to explore, but with some limit. You cannot do always exploration, right? So the first one will be right. These are very basic question. I know all of you know, but still to have idea. The learner and decision maker is the what it is called: state, reward, agent, or environment. I use many times this term. So I am learning what
Agent.
Yeah, exactly. It's agent. At each time step, agent takes. It was also here from clue was given. Previous next question was involved agent. So someone who even don't know anything and have very good kind of contextual usability, they can figure. At each time step, the agent takes what it takes: environment takes, action takes, state takes, reward. So just action. That's true. It takes an action. Again, those who don't know much still can figure out there is an then state and reward is not going to work out. So only two options is figured out. I don't know how many of you do this kind of thing in MCQ. I usually do and I don't know the answer. So this is then obviously E and action can going to work. Now at each time step, the agent takes what? Agent cannot take environment, it will take action. Now this question, if reward is +1, what is the sum of discounted infinite reward when gamma is less than 1? And gamma value is this. Just you put the value. Gamma.
1 by 1 minus gamma, right?
1 by 1 minus gamma, true. Because let's open it there and see it's 1 by 1 minus gamma or not. I think it is so. R0, which is 1, plus gamma into R1 plus dot dot dot. So you are saying R0 is 1, fine. It is always 1 or what? Oh, it is saying R0, R1 is always 1. So it would be 1 plus gamma. I can take R1 common, I guess, and then from there itself it will come to something like that: 1 plus gamma square plus gamma cube plus that. So it's a geometric progression, and it's a by 1 minus r, I guess. So a is 1 by r is here, gamma. For each time it is increasing by gamma, so it would be a by 1 minus r. So a would be 1 minus r, 1 would be r would be here, gamma. So this third option is going to work out. Now based on this you have to calculate what would be this. If gamma is 0.8 and r1 is 5, what would be g0 given after r1 you will get every time 10. So the same formula I put it there. So initial reward, what you are going to get, gamma into next reward, gamma square into next reward, dot dot dot. So initial reward is 5 plus gamma into 10, because it said every time you are going to get 10, gamma into 10, gamma square into 10 plus dot dot dot. 5 plus, it is a geometric progression, you are taking 10 as a common, and this sum we just decided it will be 1 minus 1 minus gamma. So you'll put it there, it will be 5 plus 10 into 1 by 1 minus gamma, so it will be 1 by 1 minus gamma would be what? It will be 0.2. 1 by 0.2 means 10 by 2, I guess. So it will be 5. 5 into 10, 50 plus 5, 55 would be the answer. Any doubt, any question here? No, we can go on. How does the magnitude of the discount factor affect learning? The magnitude of discount factor has no effect on the agent. Does it so? No, it has some effect. With a larger discount factor, the agent is more far-sighted and consider reward further into the future. With a smaller discount factor, the agent is more far-sighted, consider the reward further into the future. It is saying far-sighted means you are considering future more importance than present. So pretty just a synergy if I'll give. Should we enjoy today or tomorrow or day after tomorrow? Which one is more important? And gamma is controlling this factor here. Now what would be the answer? If I'll put gamma large, will I be far-sighted or short-sighted? If I'll put gamma less, will I be far-sighted or less-sighted? Let's take one case study. So overall cumulative reward was looking like R0 plus gamma into R1 plus gamma square into R2 plus dot dot dot. Let's gamma, I said it's possible between 0 to 1. Let's assume we are putting gamma very high, 1. So it will be R0 plus R1 plus R2 plus R3, like that. So it is saying you are giving importance to future reward as current itself. So with large discount factor, agent is more far-sighted, considering reward further into future. Yeah, that's true. With a smaller discount factor, the agent is more far-sighted. No, if I'll put gamma, let's say 0. Gamma I'm putting 0, so it will be only R0. I'm only seeing current reward. I'm not seeing far what is happening in future. If I'll put gamma as 0, your reward would be consider only the current immediate reward. I'll not see what is going to happen in future, right? So option 2 would be correct. So similar to real life thing, like should I enjoy today, tomorrow, or day after tomorrow, after 10 days? So enjoy today. Zindagi na milegi dobara. Theory. So whatever is possible to, but we like do optimization. Let's enjoy something today, something tomorrow. Those gamma is like how much you work, something like that. And now next week I'll discuss some more about reinforcement learning and those things. So till there, any doubt, any question, and I'll take